Okay, right. Good morning, students. Yesterday we started a topic called electric charge, and we have seen some models, right? So triangle and square models, right? And then in model two, I can set some series of charges, and at the origin, I said to calculate. One question we did, and one question I think I gave or not, I don't know. So today I'll give some more questions, right? So we'll continue that. Next model is equilibrium problems. So we call equilibrium problems or problems on equilibrium. Don't worry about that. Okay. So equilibrium problems. So what do you mean by equilibrium exactly? What do you mean by 11th for some time? Right? So equilibriums, and if you know the types of equilibriums, then this topic will be easy. First we'll go for equilibrium, what do you mean by that, and the types of equilibriums, and then we'll come back to 12th. Okay? So what do you mean by equilibrium actually? In the sense, the net force acting on the body will be equals to 0. That's all. The net force or forces. Force is not 0. Net force will be 0. In the sense, consider a particle of mass m. Basic, right? So consider a particle of mass m. So if it is at rest, in a sense, no forces are there on that particle. So I am at rest. In the sense, no forces are there. Definitely, some forces are there due to the light photons will come. Some of those type of energies will be there. And if some air is there, assume air resistive force will be there. Still, some internal forces will be there. Still, I am at rest. In the sense, what on me? How many number of forces are acting? They are cancelled each other. Yes, sir? They cancel each other. In the sense, the net force acting on the particle will be equals to 0. In the sense, for example, one force is acting in this direction called F, and another force acting in this direction called F. So opposite in the direction with the same force, I can tell net force acting on the body equals to 0. If net force equals to 0, I can tell acceleration of the body equals to 0. So if acceleration is 0, I can tell the body can be at rest or the body can move with constant speed. Yes, sir? So equilibrium cases. So body can be at rest or the body can move with the constant speed according to level. Now come back here. In the charges, what we have to discuss. Right? So if I consider two charges, they will be in equilibrium. Think about that. So for example, I can set two charges. So assume Q and Q, positive charges, separated by some distance called R. Now can I tell those two charges are in equilibrium? In the sense what? Net force should be equals to 0. Can I tell? Absolutely no. Why? So if you stand on this charge, how many forces will be there? Only one force, which is repulsive. So if you stand on this charge, so definitely only one force will be there, which is repulsive. So on this one force and on this one force, in the sense definitely they will accelerate. Force is there. If force is there, definitely acceleration will be there. So they won't be in equilibrium. Right? Clear about the point? So only one force is there here in this direction, and on this one again force F is acting in that direction to the left. Then due to this force, it will accelerate in this direction. Due to this force, it will accelerate in that direction. So now what we want? Net force should be equals to 0. In the sense what? One more force should act in this direction on this with the same magnitude. Got the point? And on this again, one more force is required in the opposite direction of the repulsive force by this on this. Then these two forces will be cancelled each other. Then I can tell these two charges will be in equilibrium. What is the point? Initially, this force will be there and this force will be there, repulsive forces. Now, those two particles should be at rest. In the sense, what we have to do? So, another force is required such that they should cancel this repulsive force. So, how I can get? So, by placing another charge along the line joining between the two charges. Where we have to place, what is the nature of the third charge? Everything we have to calculate now. Is that okay? So now, in a system, if only two charges are there, they can't be in equilibrium. They can't be in equilibrium. Why? Because only one force will be there this side, here only one force will be there in that side. So they won't be at rest if we release. If we release, they won't be at rest. They won't be at rest in the sense what? Definitely acceleration will be there. If acceleration is there, definitely force will be there. So they won't be at rest, some force will be acting. Now to cancel that force, another force required. So from where that another force will come? From where? So you have to place another charge. You have to place another charge. Where you have to place and all, we have to discuss in this first part of this equilibrium problems. Clear about that? So in this, the question will be like this: find the nature, location, and the magnitude. Find the nature, location, and the magnitude of the third charge placed in that system such that the system will be in equilibrium. What's the point? So this is for what we have to calculate for the third charge placed in that system. For the third charge placed in this system such that the system will be in equilibrium. Clear about the point? So types of equilibriums after 5 or 10 minutes we will see. Now try to understand this point. Is that clear? So net force should be equals to 0. With the two charges we can't get that equilibrium condition such that we have to place the third one. Now where we have to place, what is the nature, whether positive charge we have to place or negative charge we have to place, and what is the magnitude of that, everything we have to calculate. Alright? So start. Take a question, and with that question you can understand. And here again two cases will be there. One is what? So in that two charges, there can be like charges or there can be unlike charges too. That's how. So case 1, I will consider only like charges. Okay. So case 1, equilibrium problems on like charges. Equilibrium problems on like charges. Correct? So take a question that we can calculate everything. For example, consider plus 4 cube and plus 16 cube separated by some distance called r. Right? So two charges plus 4 plus 16 separated by r. Now only these two charges are there in the system. In the sense the system is in equilibrium? Definitely not. So that's why we have to place the third charge in that system such that the system should be in equilibrium. Clear? Such that the system should be in equilibrium. So where you have to place, that is the location, what is the nature, and what will be the magnitude. See? We'll see that. Now where we have to place. So for example, consider here, for example, q dash. We don't know the magnitude, so I assume it as q dash. Sir, why only here? Why not here? Why not here? Why not here? Why not here? Everything, if you want, we will waste some time. Okay, so try to analyze everything. So, for example, q dash, if I place here, assume positive q dash. Everything you have to consider for nature. Positive if you place, what will happen? Negative if you place, what will happen? So, positive I placed here. So, tell me the forces. Plus 4q if I place, positive, positive, repulsive force, and again positive, positive, again repulsive force. So, it's not possible. Yes or no? So equilibrium in the sense what? Two equal and opposite forces required. On the same direction if forces are there, so the force is increased. So acceleration increased. So it didn't come to rest. So positive charge placing here is wrong. Right? So you have to understand all these points. If you want, you can write those. Okay? So now negative charge I will place. So positive and negative. So I am standing here now. So positive, negative, attractive, and positive, positive will be definitely repulsive. See, opposite in the direction. Now chances are there to get equilibrium. Right? Now stand here and see. So negative, positive, attractive, and again negative, positive will be attractive. See, yes, chances are there. Now likewise, right? See. So on the three charges, you have to consider that whether the forces are opposite or not. Yes, on all the cases, on all the three charges, forces I got opposite. So I can conclude that. So the nature of the charge should be negative. What is the nature of the third charge? nature of the third charge will be negative. First question, nature of the third charge will be negative. If you want a point by saving the time, I can write, if like charges are there, the third charge always you have to place along the line joining between the two charges only. I am not telling midpoint. I am not telling midpoint. When it will be midpoint, if the two magnitudes are same, if plus q, then the third charge we have to place exactly at the midpoint. If magnitudes are different, I can't tell the third charge should be placed at the midpoint. But where we have to place? Along the line joining between the two charges. When? If like charges are there. Right? If like charges are there. Further, the story is there. We can waste time. So, consider a point here and place negative charge. What will happen? So, you have to draw the forces and one more force will act downwards if you resolve that. So one more force is there downwards in the sense it should move down. It will move down. So what I want the system should be at rest, or it should move with constant speed such that net force should be 0. Right? So if I place a point here like that, it won't be. If I consider a point here, it won't be. Won't be. Such that it will be there only along the line joining between them. Alright? So now, first one done. So I waste some time for the first question. Next question you are in a position to do. Alright? So now second one, finding the location where we have to place this third charge. Where we have to place that third charge. Location. So assume from this charge from 4q to q dash, I am assuming it as x. I am assuming it as x. Alright? So if that is x, then what about the remaining distance r and x? It will be r minus x. Got the point? So r, this is x I assume, this is r, and that will be r minus x. Now I want the location where I have to place the third charge. So on every one forces are opposite in the direction. So give some names, assume it as F1, F2, F3, F4, F5 and F6. Whenever if you are calculating the location, always you have to consider the reference point as the third charge. Remember these conditions, you can do directly the next questions. Whenever if you want to calculate the location, always you have to consider the reference point as the third charge. In the sense, you have to stand on the third charge and see how many forces are acting. Sir, why only third charge? You can understand in the calculation part. You can understand. Right? So stand on the third charge. How many forces are there? F3 and F4. So equilibrium in the sense what? These two forces should be equal and opposite already we know. So according to the magnitude wise I am writing F3 and F4 should be same. If F3 and F4 should be same, then directly directions are opposite, they will be cancelled. So I am equating F3 and as well as F4 to calculate the x value. Got that point? Now what is F3? F3? So see, direction is in this direction I have shown. In the sense, negative and positive. Attractive or not? So F3 due to plus 4q and F4 is due to plus 16q. Got the point? So F3 is due to plus 4q on q dash minus q dash and F4 is due to minus q dash and plus 16q between them. Now write the formula K, q1, q dash, 4q divided by x square. Already I said in the yesterday's class. So please substitute only the magnitude of the charge. Why? Because directions already we know. Right? So which is equals to what is F4? It is K, q dash, 16q divided by r minus x whole square. Clear about this point? So why you consider frame of reference as third charge, sir? In the sense, see, everything will be cancelled here. So q won't be there in the expression and q dash also won't be there in that expression. Now leaving this third charge as reference, if you take any one of these two, then what will happen? Q and q dash will be there. If it is there, then whatever the x value will get in terms of q1 and q2 will get. But I don't want that. I want only in terms of r, x and with some constant. I don't want q and q dash. So those should be cancelled. In the sense, definitely you have to stand on the third charge and you have to write for what? For location. Remember that point. Don't be confused. Right? So now k and k also will be cancelled. And for force, Now finally what I can write? R minus x by x whole square. This one came to this side, whole square, which is equals to 4. So what I can write? R minus x by x, which is equals to 2. Right? So 2x. So R, which is equals to 2x plus x, 3x. So where x, which is equals to R by 3. Right? So where we have to place the third charge? At a distance of R by 3 from what charge? In the options that will be there. So R by 3 from 16 cube. First option. That's absolutely wrong. So R by 3 from what charge? From 4q charge. R by 3 from what charge? From 4q charge, where you have to place at R by 3. Now at 16q, at what distance you have to place the cells? That will be R minus R by 3. That should be 2R by 3. From 16q, at this distance you have to place. From 4q, at this distance you have to place, such that the system will be in equilibrium. Clear about the point? So whenever if you want to write the location, reference point, please take it as the third charge. Then calculation part will be easy for you. Alright? And next, finding the magnitude of the charge. In the sense, what magnitude you have to place? What is the magnitude of q dash? Just I assume, let us suppose I assume it as q dash. Then what will be the magnitude of that q dash? Right? So, is that clear? Now finding magnitude of q dash. Finding magnitude of q dash. Now think about the reference point. Now q dash value we want in terms of q. Whether it is q by 2 or q by 4, options will be like this. First option, q dash will be equals to q by 2. Q dash will be equals to, let us suppose, q by 4. Like that. I don't know the answer. Okay? Like this options will be there. Now q dash and q terms should be there in the final expression. Now the reference point should be third charge, or the reference point should be any one of the other two charges. Any one of the other two charges. Why? Because I want the final expression in terms of q dash and q. Remember that point. So to find the magnitude, a reference point should be any one of the two charges. Initial two charges. Any one of the two charges, initially, what are the two charges are there? Those charges. Clear? Now, yesterday's basics, if it is clear, then today you can understand. Alright? So, leaving the third charge, any one of these two. You can take any one. So, I am considering 4q. So, how many forces are there on 4q? Again 2. So, can I equate those two? F1, which is equals to F2. Can I write? Simple. F1 equals to F2. So now F1 due to what? Repulsive force. So due to 16q. Positive, repulsive. Now positive and negative attractive. So F2 is due to plus 4q and minus q dash. So substitute, we'll get the answer. K F1 due to 4q and due to 16q divided by, what is the separation? R. So it will be R square, which is equals to K. Q1 now, again 4q. Now Q2 magnitude, Q dash divided by, what is the separation between them? It is R by 3 whole square. Another point, R by 3 whole square. So K, 4q will be cancelled. Right? Now R square also will be cancelled. 3 square 9 will go to numerator. Right? So now 16q this side, which is equals to 9, will go to numerator. So 9 times of q dash. Now q dash I can write as 16 by 9 times of q. So q dash is what? 16 by 9 times of q. Now see the options. First option, q dash is 16 by 9 times of q. Second option, q dash is minus 16 by 9 times of q. Remaining other nonsense options are there, 9 by 16 and 9 by 16. Right? Clear about this point? Q dash 16 by 9 times of q. Now, which option is the correct option? First option or second option? Definitely second one. Why? We calculated the magnitude of the charge, but nature of the charge already we know it as negative. We calculated only the magnitude of the charge, but nature of the charge already in the first part of the question only we know that should be negative. So therefore, what should be the magnitude you have? What should be the charge you have to place? According to magnitude wise, 16 by 9 times of q. But according to the sign point of view, it should be minus. So this should be the correct option. If you understand one question properly from the top to bottom, then whatever the question it might be, we can do. So that's why I'm wasting more time here. So nature, if it is like charges, always you have to place in between the two charges. So now you have to analyze. First place positive and check all the three charges. And place negative and check all the three charges. So the forces should be, for all the three charges, it should be opposite. Then we can tell equilibrium is there. Then location, keeping the reference point as the third charge, and I have written F3 equals to F4 and I got X value. If you know this, R minus X also we can calculate. Next, finding magnitude. Now, leaving this third charge, keep any one initial charges as the frame of reference. Anyone. I considered 4Q. You can consider 16Q also. You will get the same answer again. Don't worry about that. Alright? So, Q dash which is equals to 16Q. 16 by 9 into Q. So positive or negative? Definitely it should be negative. Why? We calculate only magnitude. Nature we know that should be negative. So final option should be minus 16 divided by 9. Clear about the point? Right? And next. Task 5 after the class, try to do one more question on the like charges, right? So take the values, then we'll go for unlike charges. So plus q plus 4q separated by a distance L, right? So find the nature, location and magnitude. Find the nature, location and magnitude of the third charge such that the system should be in equilibrium. Okay? Done? Next case, unlike charges. What is it? Unlike charges. So if there are unlike charges in the system, then how to calculate this equilibrium? How to calculate that equilibrium? See, for example, consider minus 4q plus 16q separated by the distance r. Question is same. What is it? Find the nature, location and magnitude of the third charge such that the system will be in equilibrium. Minus 4q plus 16q separated by distance r. Again the same story. Try to think where we have to place the third charge first. At the center, right? So consider plus q dash and analyze. So minus and plus attractive, right? So minus and plus again attractive, see. So definitely not. Okay, so definitely not in the sense place negative charge and check. So negative repulsive and negative positive attractive. Yes, got. And next on here, on this charge, negative repulsive force, negative positive. Yes or no? So you have to check all the three charges. Already I said you have to check all the three charges, not only one. So if I got two opposite forces on this, here we didn't get. On all the three charges, we have to get the opposite in the direction of forces. Then only we have to go for calculating the magnitude, or else not. All right. And next here, no need to check. So for positive, along the line we didn't get. For negative also along the line we didn't get. Then now I'll go for a point which is not in between, along the line only, Along the line, always you have to consider along the line. Already we discussed that, right? So now not in between, it's away. So now here, and one more point I will consider here. Got the point? Alright? And now check. Assume this point first, and I am placing plus q dash. Positive, negative. I am seeing this attractive. So positive, positive. Repulsive, very good. Very good, right? And next, minus 4q, minus plus attractive, and minus plus again attractive. Very good. Next, positive, negative, attractive, positive, positive, repulsive, yes. Too good. So on all the three charges we got opposite in the direction of the forces or not? Yes. So check with minus q dash. I'll waste another 2 minutes, right? So minus q dash. So minus minus repulsive force and minus and plus attractive force. Got the point? So minus and this is minus repulsive and minus that is plus attractive and next here. So minus here also minus. I am saying this now. Minus and minus will be repulsive and minus and plus attractive. So for negative q dash, for negative test charge, so it is not possible. It is not possible. So what is the nature? Nature should be plus q dash only. And next come to this point. So now I place plus q dash at this point. Check now. Plus q dash at this point. Check positive, positive, repulsive. I'll write here, or else you will be confused. That point will leave. So positive q dash, positive, positive, repulsive force, and again positive, negative, attractive force. Very good. Yes or no? Now come to this point. Positive, positive, repulsive, and positive, negative, positive and negative, attractive. Not possible. Yes or no? So not possible for plus q dash placing at this point. Now we'll place minus q dash. We'll place minus q dash. Now positive, negative, attractive, negative, negative, repulsive. Got the point? Next, plus, minus, attractive, plus, minus, attractive. See, opposite. Very good. Now come to this point. Negative, negative, repulsive, negative, positive, attractive. Very good. Now my question is how many locations possible to place the third charge? How many locations possible to place the third charge such that system will be in equilibrium? Try to continue the question. What is that? How many locations possible such that the system can be in equilibrium? How many locations possible such that the third charge we can place such that system can be in equilibrium? First option 1, second option 2, third option 3, fourth option 4. How many locations possible such that we can place the third charge such that system will be in the equilibrium? How many locations possible? Sir, point A is possible. Yes. Point B also possible. All the forces are opposite in the direction. So point B possible as well as point A also possible. So correct option what you are thinking is 2, but that is wrong. That is absolutely wrong. Why? Think according to the logic now. Magnitude is less. So don't say minus and plus. Magnitude is less. So now if I increase the distance, then what will happen? Force of this decreases. Magnitude is less, so it will be decreases fast, right? So now plus 16q. 16q, if distance is less, the force will be decreases, or distance should be more such that force decreases. Distance should be more such that it should be equal to 4q. Getting my point? Try to understand. So 4q having the lesser magnitude, so if it can move the less distance, so force can be decreases. Now 16q, magnitude is more. It should move more distance such that the force of 4q and force of 16q should be same, or else it should move the lesser distance. Definitely that 16q, we have to move from 16q away more distance compared to 4q such that the forces on q dash should be same. What the point? So assume for example this as x and write for example force by 4 cube on q dash. How much? K q dash 4 cube divided by x square. Now force by 16 cube on q dash. How much? K q dash 16 cube divided by r plus x whole square. I am considering this point. Now, is this situation possible? Take this point, point B, and write force on minus 4 cube, force by minus 4 cube on this minus q dash. How much? It will be K q dash, right? And 4 cube divided by, this is r, and assume this as x now. So it will be r plus x whole square. Assume this as x now. Okay? So now for 16 cube by 16 cube on this q dash. How much? K q dash 16 cube divided by x I consider, so x square. So at these 2 points, which situation is possible? Think about that. So now lesser magnitude, less distance. More magnitude, I have to move more distance such that the force by 16 cube on this q dash is equals to 4 cube. So the distance is more such that the force will be less, and at a particular distance this force and this force can be same. Then only equilibrium chances will be there. But here, see, 4 cube distance is more. Magnitude only less, force only less. Still, if I take still more distance, then what will happen? This force will decrease compared to this. Here, these two never be equal. These two forces never be equal, whatever the distance if you go. But if you go this side, then chances will be there at a point. These two forces on point A will be same. So that's why always we have to consider if unlike charges are there. Consider if unlike charges are there. I am talking only about unlike charges. If unlike charges are there, then what we have to consider? Always the point to get the equilibrium nearer to the smaller magnitude. Nearer to the smaller magnitude. I can tell that point as a statement and I can leave. Yes or no? I can go to the solving the question. But you have to understand why that should be nearer to the smaller charge. So that's why we wasted the time here. Right? So what is the condition now? If unlike charges are there, so equilibrium where will get? Always nearer to the smaller charge. Don't see the sign, only see the magnitude. 4 and 16. Which one is smaller? 4. So nearer to 4 equilibrium we will get. So this point is wrong. So that's why how many locations in a sense? Only one. That should be nearer to the smaller magnitude charge. Smaller magnitude. Don't see that minus. Right? Now for calculation part, I think it will be same what we discussed in the previous question. The same thing. So now what will be the nature? Already we did. What is the nature? Positive charge. So nature will be positive. And location and magnitude, hope I think you can do that. So I'll go a little fast to calculate location as well as magnitude. Alright? So start. So to calibrate the location, reference point will be third charge or any one of the two charges. Third charge, right? Give the names F1 and F2. Can I equate F1 and F2? Right? Can I equate F1 and F2? Right. So F1 due to what? Positive, and this is also positive. Due to these two repulsive force we got. So it is K Q dash 16 cube divided by X and R. So it will be R plus X whole square, which is equals to K. F2 is due to minus 4Q and Q dash, right? So it will be Q dash 4 cube divided by how much? X square. K, Q dash, Q cube, force cancelling, right? So this one and take it to other side. So 4 which is equals to R plus X by X whole square. So now 2 which is equals to R plus X by X. So what I can write? 2x minus x. So R should be equals to X. Got the point? So 2x minus x will be X, where R should be equals to X. In the sense, how much distance we have to place this X equals to the separation between them, then it is possible. Then it is possible. It is possible in the sense what? Equilibrium will be possible. Got the point? Right? Now magnitude. magnitude, right? So what is the reference point to calculate magnitude? Leaving the third charge, any one of the two initial charges. Yes or no? So consider any one of the two charges. I am considering minus 4q. Give the names F3 and F4. So I can write F3 which is equals to F4. Magnitude wise I am writing. Alright? So F3 in this direction. In the sense what? Negative, positive will be attractive. In this direction, negative, positive will be attractive. So F3 is due to plus Q dash. So it will be K Q dash 4Q divided by X. X is nothing but R. X, yes or no? So X is equals to R we calculated. So I am writing it as R square, which is equals to. And now this one to here. What is the point? So this one to here I am considering. So if I consider this one Q dash and 4Q done. Now 4Q is the reference point. 4Q is the reference point. So K Q dash 4Q divided by X. So X is nothing but R. So R square. Now 4Q to 16Q. So K 4Q 16Q again divided by again R square. So R square K 4Q and everything will be cancelled. So Q dash which is equals to 16 times of Q. Positive or negative? Nature will got as positive, so definitely Q dash according to the options also it will be plus 16 times of Q. You can cancel this one also. If you cancel this from here to Q dash, you have to cancel the total distance as 2R whole square, and from here to here also you can consider the distance. Right? From here to here you can take, or from here to here you can take. You can take this charge or you can take this charge. Don't be confused. Be confident. Try to know the story properly. That's it. What are the question we can do? Location in the sense third charge as reference point. Magnitude in the sense any leaving the third charge, any of one of the two charges you have to consider as the reference point. Any one of the two charges, initial charges. If you remember that, whatever the question might be, whether it is like charges or it is unlike charges, we can do it easily. This is the first model in equilibrium. Is that okay? So I think you can do a question now. Take a question, start doing. For example, plus 9 cube minus 16 cube separated by a distance L. Plus 9 minus 16 separated by a distance L. Right? Start doing. Okay, right. So next, this is the basic concept in equilibrium, right? So how to calculate nature, magnitude, and location. Next, still we are going deeper. So equilibrium will be divided into three types of equilibriums. Three types of equilibriums, right? So the first one we call as stable equilibrium, and the second one unstable equilibrium. And the third one we call it as a neutral equilibrium. So stable, unstable, and neutral. In 11th, I think in the chapter called work, power, and energy. In that chapter we got equilibrium, and then again further divided into stable, unstable, and neutral. Alright? So I won't go to 11th, but a basic concept I will. Okay? So what do you mean by stable equilibrium? What is unstable or what is neutral? You have to understand. So for that, I am considering equipment like this. Don't worry about that. Nothing. It's an object which is done like this. It's an object. Nothing. So at the top of this place, I place the body. Assume at the top of this surface. Assume it is a surface. Yes. Good word. Right. So on this I place the body, and here I place another body, and here I place another body. Now what will happen if I give a small amount of force at this position for that body, at this position for this body, small amount of force at this position for that body? What will happen? So assume it is body A and B and it is C. Little force I give, just what will happen? It will go to this position, right? So again it will come back to its original position. No, it won't come back to its original position, such that these situations comes under unstable equilibrium. So what do you mean by unstable equilibrium? Whether the bodies or the charged particles, it won't come back to its original position if you give a small amount of force to that. If you give a small amount of force, if the bodies are coming back to its original position, we call it as stable. Which they are not coming back to its original position, we call it as unstable equilibrium. Equilibrium in the sense, net force should be zero. Small amount of force. That's why I used a word called small. Sir, you are applying a force, no? If you are applying force, then how equilibrium condition will be satisfied? So that's why I used a word called a very small amount of force I applied. Very small. So if a very small amount of force applied, what will happen? Force almost negligible. So then what will happen? It started moving. Tendency is there. So due to the tendency, what happened? It went down. So it went down in the sense force is very small. So again, it won't be having that much energy to come back to that position. So these type of situations we call as unstable. What you have to remember according to the problems? So whatever the charges or whatever the body, it won't come back to its original position. It won't come back to its original position. We call it as unstable equilibrium. What is the point? Try to write the point. It won't come back to its original position is called unstable equilibrium. Now here a little force I gave, not more force. If it is more force, equilibrium condition only won't be there. What is the point? So you can ask, sir, here also I give more force, it will go there. Okay, it can go. Who said no? But equilibrium condition won't be satisfied. So you have to give a small amount of force such that it will oscillate there only, and finally it will come to equilibrium again. So, in the sense, the body is coming back to its original position. We call it as stable equilibrium. Is that clear? So, if you give a small amount of force, it will oscillate there only, and finally it will come to rest. In the sense, it is coming back to its original position. Whenever a body or a charges, it will come back to its original position. We call it as stable equilibrium. Now here, so if I give little force or not, again it will be in the same level only, no? It will be in the same level. It will be in the same level. In the sense what? Potential energy will be constant. Yes or no? Here how much potential energy will be there? If I give the small amount of force from here, it shifted to here. Potential energy didn't change. Here it changes. Slowly change, and finally it came to its original position. So wherever you go here, it will be constant. So that's why we call it as neutral. Neutral, no change. Neutral in the sense, no change. So those type of equilibriums we call as neutral equilibrium. Why I said this topic? Important for the charges. Now see, situation will be like this. You have to tell whether that situation comes under stable or unstable or neutral. Take that situation and try to analyze. For example, consider two charges, plus Q and plus Q. What the point? Plus Q and plus Q separated by some distance called 2L. Two charges separated by a distance called 2L. Okay? Right. So now at the midpoint of the two charges, assume this distance is L and assume this distance also L. And at the midpoint of the two charges, I placed another charge. Assume plus Q again. Okay, so I placed another charge which is plus Q. Now try to understand whether the system will be in equilibrium or not. First point. Try to analyze. System will be in equilibrium or not? Yes, definitely. Why? Already I said, if magnitude of the two charges are same, then the third charge what we are placing definitely should be in the midpoint. Should be at the midpoint, right? So at midpoint only I placed. Yes or no? Definitely the system will be in equilibrium only. What's the point? Definitely the system will be in equilibrium. Whenever you are applying these types of equilibriums, before applying that, first the system should be in equilibrium. Then only you can apply this. If system is not in equilibrium, sir, I will apply stable. Nonsense. We can't apply. Right? So first equilibrium condition should be satisfied, then only these things we can apply, or else no. Okay. Now here system is in equilibrium. Now try to analyze the situation. Now this charge, third charge, I am displacing a small distance called x. Right? So this plus q I displaced by a small amount of distance called x. So where x is much less than L. What will happen to that charge? What will happen to that charge? So it will go and again it will come back, or it will be there only, or it will be attracted by the other charge or attracted by this charge. What will happen? If x is much less than L, this condition also important. If this condition is not there, some other options will get. If this condition is there, option will be changed. So options will be like this. The motion of the third charge is periodic. I'm not writing the statement, you can write. The motion of the third charge is periodic, alright? And the motion of the third charge is simple harmonic motion. Whether it is periodic or simple harmonic motion, or periodic but not simple harmonic. Both are same, I think, first option and third option. So assume this as first option and remove this. Right? So periodic but not SHM, SHM. I can't write SHM but not periodic. Right? So if periodic condition satisfies, then only we have to go for SHM, simple harmonic motion. Try to understand? Try to understand, not that much difficult. So for example, positive charge, it went x distance. Then what will happen? Try to analyze the situation. Now assume the charge is here, plus 2. Same charge. It is displaced the x distance. Now, what is the distance from this charge? It will be x plus L. And what is the distance from this charge? It will be L minus x. Now, due to the second charge, assume this is first charge and second charge. Due to the second charge, what happened? Distance decreases. If distance decreases, force increases. Attractive force or repulsive force? Repulsive force. So, distance decrease, I am saying this charge. Distance decrease, so force increases, repulsive force increases, so again it will go back. What is the point? So again it will go back. So now it will be here or it will be somewhere around here, it will be here. This is mean position. Try to understand the point. This will be the mean position. So from mean position I went some distance. So force increases. 2 more on me by that charge. So what will happen? It will throw me. So this is mean position. I want to be at mean position. One step back. Why force is more? What is the point? Force is more. So assume mean position. From mean position, one step forward I went. So force is more. So mean position, from mean position, again you have to go one step back. Now if I went one step back, then what happened? Distance from the first charge decreases. Distance from the first charge decreases. Yes or no? Now what will happen? Again it will apply more force. So what will happen? This is mean position, and from mean position, one more step. Got the point? So again decrease with respect to this. So again from mean position one step. So again force increases. What will happen? Continuously this will happen or not? So continuously with the regular intervals of time this will happen. So you can tell sir periodic motion at regular intervals of time this is happening. So it might be periodic. It will be periodic if this condition is not there. Try to write those points. Periodic is absolutely correct if this condition is not there in the question. This x is not small compared to this L, then definitely you have to go for periodic. If this condition is there in the question, then definitely you have to go for SHM. Why? Because I'll prove that. Okay, give me a time, sometime. Okay, try to understand. If this condition x much less than L, if it is there in that question, then SHM will be the correct option. If this condition is not there, some distance they moved and they left, then what will happen? It will be there. That we call as periodic motion. That won't comes under SHM. Why it won't come? If this condition is there, what is SHM condition? Anyone? F which is equals to minus k times of x. Whenever the force, net force, here net force we can calculate or not. Whenever the net force is equals to minus k times of x, displacement. X is what? Displacement. That is x. If this condition satisfies with periodic, then we have to go for SHM. If this condition is not satisfied with periodic, then only periodic. What is the point? With periodic, if this condition satisfies, then SHM. With periodic, if this condition is not satisfied, then only periodic. Now, this condition satisfies or not? Now we will see. Understood the story? Right? It went in this direction, force is more, so one step back. This is mean position and this is extreme position, right? So one step back, how much distance it will go? Again, x distance only. So amplitude will be same. If they ask about amplitude. So x distance forward, x distance backward. And again x forward, x backward from the mean position. Got the point? Now, whether it satisfies SHM or not, so how we can calculate? Previous questions are there, so please try to concentrate. Only two problems I will tell here. What is that? Along the axis, perpendicular to the axis. Now, before going to the calculation part, one task for you. Tell me, negative charge placed here. Now, it is stable equilibrium or unstable equilibrium? One more question. Try to write. This situation comes under stable or unstable or neutral. This situation comes under stable or unstable or neutral. Stable or unstable or neutral. So it went x distance forward. So by going x distance forward, again it came back to its original position or not. So again it went x and again it came back. So always it is trying to come back to its original position. So definitely I can tell it comes under stable equilibrium. It comes under what? Stable equilibrium. Clear about that point? Alright, now SHM or periodic, it depends on this expression. But definitely I can tell it is stable equilibrium. With this condition or without this condition also. With this condition or without this condition it comes under stable. But periodic or SHM depends on that condition. Got the point? Now take this situation and tell me whether it is stable or unstable first. Two negative charges. And I placed here a positive charge. And I displaced by x distance. And assume total length is 2L and assume this length is L and as well as this length also L. Got the point? Two charges. In between I place a positive charge now and I displace the x distance. This situation comes under stable or unstable or what? Stable or unstable or what? Neutral. Please for a minute think about that. Think about that. So now x distance, now distance with respect to this increase, how much? X plus L, and distance with respect to this decrease L minus x. Is that clear? L minus x. Now with respect to this, what happened? Distance decreased. Force increases. If force increases, what type of force increases? Attractive force or repulsive force? Definitely it is attractive force, so it will go. So it won't go back to its original position. It will be attractive forces are more. If attractive forces are more, then what will happen? It will be attracted by this charge. Definitely it won't go back to its original position. So this situation comes under unstable equilibrium. This situation comes under unstable equilibrium. Why? Because it doesn't go back to its original position. Now here, so it went, repulsive forces are more, came back, and again here repulsive forces are more, and again it went. So it comes under stable equilibrium. Got the point? Now we will calculate whether the given situation satisfies this f equals to kx or not. Okay? Okay? Okay, right? So we'll calculate net force equals to minus kx, right? So find the net force now at this point. So consider any point you can take. So I am considering this point, and here I am calculating net force. So tell me how to calculate net force. So at this point, positive, positive, repulsive force, and again positive, positive, repulsive force. So this will be F1 and this will be F2. Now F1 is due to these two, distance is less, the force will be more. What is the point? Now F2 due to these two, distance is more, so force will be less. So force will be less. So therefore, net force I am writing it as F2 minus F1. Got the point?